Good morning. SE sequential series part 2. Sum of the first n even numbers. Sn equal 2 plus 4 plus 6 plus 8 plus 2, 8 plus 10 plus dot dot to n terms. What is the sum? The sum is n into n plus 1. N into n plus 1. Another sum of the first n odd numbers. So the first n odd numbers, that is Sn equal 1 plus 3 plus 5 plus 7 plus 2 n terms. 2 n terms, that is n square. If you take 4, 1, 2, 3, 4, the sum is n square. 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, that is 4 square. If there are 4 terms, that is 4 square. 5 terms, 5 square. 6 terms, 6 square. It makes the sum easier. Another, AP and GP, that is for beginners, sequential series. Today we are dealing with some formulae. Let A and B be any two real and unequal numbers. Unequal number. There are two terms A and B, and they are real and unequal. The arithmetic mean AM between A and B equal A plus B by 2. How to prove? You can easily prove in this way. Let A M B be in AP. If any terms are in AP, their common difference is equal. How to find the common difference? The common difference is second term T2 minus T1 equal T3 minus T2. That is T2 minus T1 equal T3 minus T2, because common difference equal T2 minus T1, T3 minus T2. Common difference. See, common difference is equal. Second minus first equal third minus second. Or M. M should be on left side A plus B. Transpose on the left side. Minus becomes plus. Or M plus M twice M equal A plus B. Therefore, M equal A plus B by 2. Or you can prove it. M equal A plus B by 2. How to prove? M is the arithmetic mean between A and B. That means A, M, B are in AP. If you can change into SP, harmonic progression. 1 by A, 1 by M, 1 by B are in harmonic progression SP. But we are not dealing with this. A, M, B are in AP. That means M minus A equal B minus M. T2 minus T1 equal T3 minus T2. Or M plus M equal A plus B, or twice M equal A plus B. Therefore, M equal A plus B by 2. In this way, you can prove the formula. Another is uh, geometric mean. Geometric mean between them. Another is how to prove that geometric mean or geometrical mean, say GM, between, say I have written A and B. You can write X and Y is under root XY. Under root, the product of the first and the second terms. How to prove? Solution. How to prove it? Let geometrical mean between x and y. Let m be the geometrical mean. I have already written the full form. GM for geometrical mean. That is geometrical mean. Let m be the geometrical mean between two numbers x and y. There are two numbers x and y. Therefore, x comma m y are in a geometric progression. GP for geometric series or geometric progression. X र y को बीचमा m geometric mean हो. That means x, m and y are in a GP. That means the common ratio is equal m upon x equal y upon m. While solving the problem, this technique is very important, because the common ratio equal T2 by T1 equal T3 by T2. This is the common ratio. The common ratio is T2 by T1 equal T3 by T2. Cross multiply m square equal xy, or taking the square root plus minus root xy. Proved. Hence, how to find the geometrical mean between any two numbers? Any two numbers are x, y. M is the geometrical mean. M should be written in middle. X, m and y are in the GP. That is, common ratio is equal. Common ratio is m upon x equal y upon m. That is T2 by T1 equal T3 by T2. Cross multiply m square xy. Take the square root, m equal plus minus under root xy. So the arithmetic mean between xy is x plus y upon 2. Geometrical mean between GM is plus minus under root xy. And another question, how to prove that? Prove that arithmetic mean is more than geometric mean between A and B. There are any two numbers A and B. The geometrical mean is less, and arithmetic mean between any two numbers, any two real and unequal numbers is greater than GM. GM भन्दा AM ठुलो हुन्छ. Solution: there can be any numbers, not only A, B. You can in many books, in the book it is given A and B, but you can write X, Y. Let me write X and Y. Okay. Between X and Y. Prove that the arithmetic mean between any two numbers x, y is more than 0. Solution: let x and y be two real and unequal numbers. They can be equal, but suppose they are unequal and real. Then what happens? What is the arithmetic mean? Arithmetic mean between x and y, that is AM equal x plus y upon 2. If you take A and B, A plus B by 2. Geometrical mean between x and y, GM equal under root x. We know it. I have already proved it. Okay? Geometrical mean GM equal under root xy. To prove AM is more than GM, that is, or x plus y upon 2 is more than under root xy. How to prove x plus y upon 2 is more than xy? This technique is very important in higher classes as well. In higher classes like analysis, real analysis, and in logics, in set theory, in complex numbers, especially in complex number for class 11, this theory is very important. How to prove x plus y upon 2 is more than this? Proof. The common difference between them should be greater. That means now let's take AM minus GM. AM is greater than GM. It means the difference between AM and GM is should be positive. But AM x plus y upon 2 minus root xy equal to, take LCM 2, then x plus y minus 2 root xy. Take LCM. X can be written as root x whole square plus y root y whole square minus twice root x into root y upon 2. X root x whole square, y root y whole square minus 2 root x into root y. That means a square plus b square minus twice ab equal a minus b whole square upon 2. The formula is because a square minus twice ab plus b square equal a minus b whole square. This is the formula. Apply this formula. If there is root x minus root y whole square, it is always positive, which is always positive for all real values of x and y. This is positive, means AM minus GM is positive because x and y are real and unequal. If root x minus root y is negative, the whole square of negative is positive. If it is positive, whole square is always positive. This expression root x minus root y whole square upon 2 is always positive. That means AM minus GM is positive. It shows that arithmetic mean between any two numbers is greater than the geometric mean. That means x plus y upon 2 is more than under root xy. Proved. How to prove? First, we know AM equal x plus y by 2, GM root xy, right, root xy. Take LCM, change in the form of root x minus root y whole square. Whole square is always positive for x and y are real and unequal. Therefore, AM minus GM is positive. It means AM is greater than GM. That is, x plus y upon 2 is greater than root xy. Proved. Now, I am going to solve another sum. To study theory is very important. How to prove that the sum of n numbers of the arithmetic series AP is n by 2 twice a plus n minus 1 into d. Sometimes this theory should also be proved. यसलाई प्रुभ पनि गर्नुपर्छ. How to prove? Solution. Without wasting time, I am going to write down. Let A, D, N and L be the A is the first term. It means क्रमसँग A is the first term, D the common difference, N the number of terms and the last term respectively in AP. There is an AP. A is the first term, D is the common difference, N is the number of terms and L is the last term. So we can write in this way. Thus, in this way, you can write A equal Sn, sum of the terms. First term plus second term is A plus D, because in arithmetic progression AP, the common difference is D. D ले बढ्दै गएको. D may be positive or D may be negative. A first term plus second term A plus D, third term A plus 2D plus. There are so many terms, therefore I cannot write all the terms. There are so many terms, infinite numbers. A plus D, A plus 2D, then what to write? L minus 2D plus L minus D plus L. We can write first term, second term, third term, third last term plus second last term plus last term. सबै जोड्दाखेरि के आउँछ? सम आउँछ. सम भन्नाले first term plus second term, third, fourth, fifth, sixth. Then suppose I have written first, second, third, 3 terms. There are so many others. Plus last term, second last, third last. You start from this. Third last, first term, last term, second term, second last term, third term, third last, fourth term, fourth last. Last part, it can be written. This equation, it can also be written as Sn equal from the last term should be written here. Your last line is L plus the second second last is written just below the second term, third last below the and here L plus 2D, third last, third term A plus 2D plus A plus D plus A. Alright, you can write in the reverse order. It can also be written in the reverse order. It is also called reverse order. It is called reverse order. See, first term, second term, third term, third last plus second last plus last. Sn, last term, second last, third last plus then third term plus second term and last term in the reverse order. See, third term, second term and first term. Now adding equation 1 and 2 by adding what? Sn plus Sn twice Sn. See, first term and last term, right? A plus L within the bracket plus this dd cancel, A plus L plus a plus l plus another 2 n terms. There are n terms. यस्तो n terms हुन्छ. There are n times a plus l. How many a plus l are there? There are n times a plus l. Therefore, we can write